Let's now take a look at a couple more examples where we're going to be solving some equations of different types. So first, suppose y equals 1 over the square root of x plus 3, and I would like to find a value of x that results in y equals 5. So like we've done before, I just substitute in 5 for y, and that gives me 5 equals 1 divided by the square root of x plus 3. Now what I decided to do was get rid of the radical, and so to get rid of the radical, I chose to square both sides, which is a legal step. And when I square both sides, the left becomes 25, and the right becomes 1 squared, or 1, over the square root of x plus 3 squared, which just gives me x plus 3. Now, I thought of 25 as being 25 over 1, and then I cross-multiplied. And so when I did that, that gave me 25 multiplied by the quantity x plus 3 equals 1. Now I have a relatively straightforward equation to solve. I have 25 plus 75 is 1. Subtract 75 and divide by 25 gives me x equals negative 74 over 25, which I could write as a decimal because this comes out as negative 2.96 as an exact value. Please, if it comes out to be a non-exact number, do not write it as a decimal. Now I could do this graphically, and we discussed this before, this idea of using intersect. If I wanted to do that, I could go into my y equals on my calculator and make y1 equal to 5 and y2 equal to 1 divided by the square root of the quantity x plus 3. And I could graph those, and what I'm then looking for is the intersection. Again, if you don't remember how to do intersect, let me know and we can go through this. Notice again, when I do the intersection though, I get both an x and a y. In this case, I already know y is 5, and so I only give the fact that the answer is x is negative 2.96 or negative 74 over 25. Let's take a look at one other example. Suppose A equals Q of R is the area of a circle with radius r centimeters. What is the radius if the area is 25 square centimeters? So algebraically, I need to remember the area of a circle, and the area of a circle is A equals pi r squared. We've seen that a couple of times so far this semester. Now we know the area is 25 square centimeters, so I can put 25 in for A, and now I need to solve for r. And again, we've done this algebra before. So to solve for r, I'll divide by pi to get the squared r squared by itself. And then I'll take the square root. And then technically, remember, there are two square roots. There's a positive square root and there's a negative square root. But we do want to look at the radius, and so it really doesn't make sense to use the negative. So therefore, the answer would be r equals a positive square root of 25 over pi. This is one of those cases where, because it's a real-world problem, we might want the decimal. Otherwise, the exact answer is the square root of 25 over pi. Again, graphically, I could do the problem. I could make y1 be 25 and y2 be pi x squared, graph it, and use the intersect feature. Again, only getting the positive value because I'm looking for the radius.